All right, we're doing a little review here for our similar triangles unit. So hope you enjoy the background here. Some little frozen action. Just for me to write on, but all right. So review of right triangle similarity proofs. Let's start with number one. See if we can limit the frozen in the background there. All right. So we want to know whether or not these triangles are similar. If they are, we're going to do a similarity statement and name the theorem. If not, we'll explain. So first of all, these two triangles, we have the top one and the bottom one. They share angle Q. That's about it. So we're looking for side angle side here. That's what we want to check for. So this whole side is 10. That one is 8. So the question is 3 over 10 the same as 2 over 8? It is not. So these are not similar. And we can just put down side's not proportional. All right, second one. So we don't have any angles, we just have sides. We're going to check for side, side, side. So we got 8 on the small side, 12 over here. The biggest one is 24 over 36 is the biggest. And then there's 20 over 30. So take out a 4, we get 2/3. Take out a 12, we get 2/3. Take out a 10, we get 2/3. So these are all equal to 2/3. So yes, they are similar. And side, side, side. Similarity. Remember, I need to see the proportions to justify here. Okay, go down the line here. So we got 75. The small side here is 50. We got 60 on this side. The small one is 40. And they both share angle H. So we're checking for side angle side again. All right. So 75 over 50, is that the same as 60 over 40? I can take out 25 here and get 2/3. 20 here, or 3 over 2, 3 over 2. So these are proportional. So it is yes. And then side angle side. And the last one, we're going to check for angle angle here. We have 76 and 48, which is 14. That's 11, so 124. And then 180 minus 124 is going to give us 56 for the third angle here. And then we have 63 plus 76. That's 9. So 139. 180 minus that is 41. So none of these angles are equal. So no, they're not similar. Angles, you just say, are not all equal. All right, down to number 5 here. Explain why the triangles are similar. So same idea, same concept here. We have two angles, pairs of angles congruent. So this is angle, angle, similarity. Oh, we forgot to do similarity statements. So we said this one was, so we're going to say triangle A, B, C is similar to triangle. So A pairs up with O because it's stuck in between the big and the medium side here. So O, we put B next, which was out on the side here where P is, and then N at the end there. This one was also yes. So the small triangle is triangle HIG, and that's similar to triangle starting with H again, going down this way, and that would be HEF. All right. So 5 we have going back up. Why are the triangles similar? We got angle, angle, and then we're going to do a proportion. So you can see these two sides are corresponding. There's a small, those two, so we can do 2x over 21 is equal to 40 over 11x plus 4. We can then multiply both sides together. So 21 times 40 is 840. And then distribute, we're going to get, I'm going to tell you right now, if you're doing this one, stop, don't do it. This is a beast of a question. We have this on our worksheet. This is 22x squared plus 8x. We're going to get everything equal to 0. So we get 22x squared plus 8x minus 840. We're going to divide everything here by 2 on both sides. So everything is divided by 2. We get 11x squared plus 4x minus 420. So we're going to try to factor this thing, which ought to be fun. You can also check the graph here. So if you wanted to do 11x squared plus 4x minus 420, and we can go to our graph, and this is an older calculator. This is in 84, but same thing. If you see the graph, you can see this one hits is not a nice number. It's not a whole number. It's hitting in between these two numbers, but this one hits perfectly on that line. So if you go to your table, and you can actually do the, you can't do this on yours, but your table said if you start at 0, this to be auto. So you can see when the x is 6, the y is 0. That is one of our solutions. So we have like one of the numbers we're looking for is 6, and then the other one is not so nice. So it gives us an idea here. I would, if me doing this, I would be using the quadratic formula. So let's go through that. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We see a here is 11, b is 4, c is negative 420. So we're going to get negative of 4 plus or minus the square root of 4 squared minus 4 times 11 times negative 420, all divided by 2 times 11. So we have negative 4 plus or minus, and the square root, I'm just going to type all this stuff in so you guys can kind of get an idea of what this is going to look like on the calculator. Okay, so once again, this is an older version, but you can get the idea here that what we're doing. So just 4 squared minus 4 times 11 times negative 420. And I get 18,496 divided by 22. And the question is, does that give us a nice square root? And actually it does. So this becomes x equals negative 4 plus or minus 136 over 22. So I'm going to split this up into two options here. X is going to equal negative 4 plus 136 over 22, and x is going to equal negative 4 minus 136 over 22. So what's 132 over 22, and what is negative 140 over 22? I bet you this one's 6. And it is. Or, and we get this really not fun number, right? To math, which is just negative 70 over 11, or really just that answer, right? We can just leave it as negative 140 over 22. That's our answer. So those are the two answers we get. That's our quadratic formula work. Okay, number 6. Same thing. Here we're going to use our triangles. So we want to do x plus 6 because I'm going to do small to big on this one. And then, right to the bottom, right to the bottom. So let's go with the first one. So 6 over right over the bottom, x minus 1 equals right x plus 6 over the bottom, 2x plus 4. We're going to do another quadratic here. So x minus 1 times x plus 6 is going to equal 6 times 2x plus 4. You can do that all at once if you want. I'm just trying to show you what's going on. We distribute. So x times x is x squared. The outers is 6x. The inner is negative 1x. So that's going to be 5x. And then minus 6. This becomes 12x plus 24. We want to get this equal to 0. We want to keep the x squared positive. So we want to bring this stuff over to the other side. So x squared minus 7x minus 30 is equal to 0. If I do my diamond here, I want to multiply negative 30, add the negative 7, that's negative 10, positive 3. So x minus 10, x plus 3 is equal to 0. and then I get my two solutions. So if x minus 10 is equal to 0, that means x is equal to 10. If x plus 3 is equal to 0, that means x is equal to negative 3. We are then going to reject that answer. Remember, we can't have any negative lengths here. We're good to go. Also, why is this proportional? Once again, it's angle, angle. Parallel lines share these corresponding angles, which are congruent, and then that angle is reflexive. So, angle, angle similarity. This guy right here has angle in the middle congruent. That's all we know. We do have proportional sides. We do have these sides that are corresponding. So the question is 9 over 12 equal to 21 over 28? Take a 3 out of these. We will get 3/4 for both. So this is side angle side similarity for this one. And then we'll solve. So you see that this one is paired up with this. And then we have like the 9 and the 12 that go together. So we can just do 9 over 12 again equals, and then 18 over 4x minus 4. The reason we're doing, I just chose the 9, 12 goes with it. So 9 to 12, and then coming back to this triangle to that triangle. So cross multiply, I'm going to get 9 times 4x minus 4, 12 times 18 is 216. Distribute, so 36x minus 36. We'll add 36 to both sides. Next step is divide by 36. So this gets us to 252. Divide by 36. We get an answer of 7. Last but not least, we could actually use side, side, side similarity or angle, angle here, because since these are equilateral triangles, all these angles are guaranteed to be 60 degrees. So there's another option for you. And then we're talking about side lengths. So just make a proportion of 10x minus 10, which is the left triangle, over the right is over 2x, and then 10 over 4. Cross multiply 4 times 10x minus 10 is going to equal 20x. So 40x minus 40 is equal to 20x. Couple different ways to do this. I don't mind bringing this over and getting a negative. If you don't like negatives, move the 40 over. So this will eventually turn into 20x and then equals 40. So move the 20 this way, the 40 that way. I don't mind the negatives. Just be careful with the signs. So the number that the sign in front stays with it. But if you would rather keep this positive, then by all means, please do so. You can't even see any of that. Oh my gosh. Let's try that again. So we can check here, side angle side. We did 9 over 12 from left to right, cross multiplied, distributed through, move the 36, divide by 36 to get this. Same thing here, these angles are all 60, so angle, angle, or proportional sides, because if you have like 6 and let's say 4, all of them are 6 over 4, so that'll work. And then we just do the proportion. So 10x over 2x, so left to right, cross multiply. And here's where we're talking. At this point, if you want to move this 40 over here and bring the 20 back, you can do that to get this, or just divide by 40, subtract the 40x to negative 20x, and then you can just divide out and solve. All right, sorry about that. All right, and the next one, we want to prove that when we multiply these sides together, they're going to equal each other. This is a similar triangle proof. So just be aware, we need to first identify the triangles. We got them. We want to make a proportion to get this. So if you're doing the proportion, essentially you just want to bring one of these over here and bring this one back. That's it. So if you think about it, I want WT on the top here. I want HT underneath. That leaves AT on the top over here, and then CT underneath. You can also just identify your triangles and then using the sides create a proportion that's going to get you there. But that's it. So T-chart, statements, reasons. Hope I left enough room on this. If not, I will make sure yours is edited down. So WT, we know we're doing the top and the bottom here. All right, we got vertical angles, but we're going to go through the givens. So we know that WA is parallel to CH, and then WH and AC intersect at T. So that's our given. We got vertical angles right there. Don't have to have that. You can actually skip that step and do the next one and be done, be able to get similar triangles, but we'll put it in. So angle WTA is congruent to angle HTC, and that's just going to be the vertical angles are congruent step. Now, because these lines are parallel, these angles are alternate interior angles. So like I said, you could have skipped step 2 and just done angle A is congruent to angle C, and then angle W is congruent to angle H. So 2 parallel lines cut by a transversal, and then just alternate interior angles are congruent. 4, we have triangles are similar. So triangle WTA is similar to triangle, careful, W equals H. So it should be HCT. And that's just angle similarity theorem. Now we're going to do our proportion. So we're doing WT, right? And actually, if you can see, it's WT over WH, right? WT over WH equals, or sorry, HT. What am I talking about? HT, WT, HT, and then going back AT, CT, right? And this is just like CPCTC, except we got to write it out. So corresponding sides in squiggly triangles, right? Similar triangles are proportional. And then 6 is going to be our proof statement. WT times CT equals HT times AT. And then this is just going to be multiplication property of quality. And that's it. Okay. So we have these, we want to prove the triangles are similar. We know that CAB and CED are equal. This is extremely easy to do. So our given, we have triangle ABC, triangle EDC, AE intersects BC at C, and angle CAB is congruent to angle CED. That's given. All right, just vertical angles, guys. That's pretty much it here. So how about we move up? All right, man, that's twice now. So angle. Which one of you guys yelling at me here? I'm sure you guys are. Angle ACB and angle ECD are congruent. Vertical angles are congruent. Now, technically, you could have also done these are alternate interior angles. X makes these lines parallel, and then these are also alternate interior angles. Could have been a couple more steps. So you parallelize alternate angles, and then it's an extra step here. We're done in 3 here. Triangle ABC is similar to triangle EDC, and then this is just angle similarity theorem. Okay. All right. Little right triangle similarity. So remember, when we see this, we're going to draw out our 3 right triangles. We draw the big one, we draw the medium-sized one, we draw the small guy. So in the big one, we have sides of 6 and 8. In the medium-sized one, we just have a side of 8, which is the hypotenuse here. Okay. And then in the small one, we have sides of 6 with the hypotenuse. X is the short leg. And you can see we're running into a problem here because this is one where we're missing that side. I need it. I don't have it, but I have these two. So I can use Pythagorean theorem to go get it. So 6 squared plus 8 squared is equal to c squared. That's equal to 100. And take the square root, and I get a value of 10. So now knowing that, I can do 6 over x equals 10 over 6. So 6 over x, 10 over 6. I get 10x is equal to 36, which means x is equal to 3.6 when you divide both sides by 10. So pretty easy. And then AD is equal to 3.6. The only thing that was hard was that I had to use the Pythagorean theorem to get this. After we did this problem, I remember on the quiz, a lot of you guys just pulling out Pythagorean theorem for some random reason. Just draw your triangles and label them out. If you're missing a side and you have the other two, then you can use it. But you don't always need it, and it's predominantly not seen a ton with these questions. So just keep that in mind as you're working along. Okay, here's another one of these. Got a ladder, it's 24 feet long, leaning against the building. This piece is 10, which means this is 14. Okay, and I'm looking for x. So once again, I'm going to draw my, looks like this now. That's my right triangle. This is a short leg. Hypotenuse, that's the long leg. So we want to draw 3 of these guys out for ourselves, right? Okay. So in the small triangle on the right, I got a long leg of x, short leg is 10. Remember, this cuts this into a long leg and a short leg. So this short leg is a short leg in that triangle. That long leg is a long leg in that triangle. So that's 14 in x. And then there's my proportion. So x over, let's say 10, is going to equal 14 over x. So I get x squared is equal to 140. I bust out the square root of this. I know it says what equation we use to find x, but actually, you know what I want you to do is just find the length of x, okay? And if we're doing simplest radical form, we want to break down 140. So that's 14 and 10. That's 2 and 7. 7. Well, terrible. 2 and 7. And this is 2 and 5. So really in the square root is 2, 2, 7, and 5. Take the 2's out. I get x is equal to 2 radical 7 times 5, which is 35. And there's my simplest radical form. All right, number 13, shown in the diagram below. We got 12 and 3. They want to know what the length of AB is, which is right here. Keep in mind we know the length of this is 15. Okay, and then once again, I'm going to draw my not drawn. So we have this guy, medium, small. So big triangle, just have x over here. Hypotenuse is 15. The big triangle, hypotenuse we don't know. The long leg though is 12. I know, kind of weirdly drawn. Not my forte in this part, so to speak, when we're doing this. And then here on the small triangle, we have a hypotenuse, which is x. We have a short leg, which is 3. And then there's our pairs. So we can go 15 over x equals x over 3. And then cross multiply, we get 45 is equal to x squared. So bust out the square root. 45 is really 3 times 3 times 5. Take out the 3's, and we get 3 radical 5. 5 equal to x. Yeah, that's a 5, people. Just be aware. Okay, going down to the bottom here, AT is 5, TB is 7, AV is 10. What is the length of VC? Just an easy top to bottom split. So 5 over 7 equals 10 over x. You can cross multiply and solve. 70 is equal to 5x divided by 5. And we're going to get 14 equal to x. And so that is also the length of VC. Just be careful they didn't ask for AC. If they did ask for AC, you know it's going to be a little bit different because now we're going to do like the whole, top to the whole, top to the whole. Or after you get this, which is 14, you're going to add that together to get that. Okay, triangle down below is a ratio. Anytime you see a ratio, please remember we're attaching x's onto these, and then we're developing an equation. Angles in a triangle, they add to 180, and now I can solve. And even I want to know what type of triangle it is, so make sure we get our values of our angles here. So this is 5 and 5 is 10x is equal to 180. Divide that out, so x is equal to 18. So my 2x angle is really 2 times 18, which is 36. My 3x angle is 3 times 18, which is equal to 54. And then my 5x angle is equal to 5 times 18, which is equal to 90. So this is a right triangle. It's also scalene, by the way, because no sides or angles are equal. All right. Number 16, triangles RST and XYZ are drawn below. If RS is 6, ST is 14, XY is 9, YZ is 21, angle S is congruent to angle Y. Are they similar? So they have congruent angles which are corresponding. So what we want to know is 6 over 9 the same as 14 over 21, which the answer is yes. So side, angle, side, similarity would be yes. And then we're good. All right. Number 17, same thing. All right, which relationship must be true? So this is a clockwise rotation followed by a dilation, which means these two triangles are similar. So we know that triangle ABC is similar to triangle DEF. So are they angles in a relationship of 2 to 1? This answer is always no. The angles should be equal, so technically this ratio should be 1 to 1. Okay, next thing we're going to do is check our angles. So, is angle A over angle C? So this is here's A, there's D. Okay, we know E matches up with B, and that C should go with F. So if we put the same angle over itself, like A over D, it's going to give us 1. So just make sure these are in the same position. So A over C is 1 and 3 arcs. F of D is 3 and 1. So this is wrong. This should be flipped. You know what I'm saying? 1 arc, 3 arcs. Bring it back down. This is F over D. That's 3 to 1. So that's not good. So now we have B and E. B, 2 arcs. E, 2 arcs. C, 3 arcs. F, 3 arcs. We're going from small to big. So these line up. And that's the one we want. 18. Shown below in the diagram, AC is parallel to BD. Booyah. Booyah. These are equal. These angles are alternate interior, so they're going to be equal as well. Which equation is true? And now we're just looking at our sides. If you have colors, this is a great way to like highlight and identify. So for example, this side is red. CE corresponds between the 2 and the 3. That side is my red side. If I had another pen here, I would highlight this in, let's say, green. I'll just put a G for green, right? And then there's blue or whatever. So keep in mind. So CE, red over red, okay? And it's going from big to small, right? Big to small. And then we go EB over AE. This time we're going small to big. So this is upside down. AE, BE, it's going big to small again, and they line up. AC, DB, big to small again, and lining up. So this would work. You can go down the line here, right? EC, AE. So it's red to green in the top. Here we go, red to green again. Red. Oh, nope, it's green to red. So this should be switched, right? And that's out. And then we have ED, so red over red. And then once again, green over green, but once again, these are flipped, right? They're going from small to big. Here I'm going big to small, so that's why that one's out too. All right, so just make sure you check your ratios, use your colors, identify big to small, and you guys will be able to answer this pretty quickly. All right, hopefully this helps. Take-home test, sorry, open book test, did it again, is going to be on Tuesday.